Hello everyone, it's Wilson here. Today let's continue to talk about solving differential equations. And as you can see that this equation is a first order linear equation, but it's not in its standard form. And then you may say, what is the standard form? The standard form is actually quite simple. So let's actually just write it down right here. Let's just recall the standard form for a first order equation. Okay, would be dy over dx plus p of x, y equals q of x. Okay, as you can see that this is almost in the standard form. All we need to do is to move the 3y to the left side of the equation, and then we can actually get it into the standard form. So let's actually do that, because once we do that, then we can actually start solving this equation. So we are going to write dy over dx, and then subtract 3y from both sides of the equation, and then we get e to the 2x on the right hand side of the equation. And then we can actually also write down what p of x is and what q of x is. And so as you compare the equation with the standard form, you can actually see that the stuff attached to the y is the p, right? So in this case, it would be negative 3. So we get p to be negative 3. And then what about the q? The q is going to be e to the 2x, because that's the function on the right side of the equation. Okay, so now what we're going to do is that we are going to solve this equation by the method of integrating factor. So what we do is that we are going to multiply the whole equation by an integrating factor, and we call that mu of x. So we have a non-zero function here that we are multiplying, because if we multiply everything by 0, then we basically just kill the whole equation, right? So we multiply by mu of x, and then 3y equals, and then we get mu of x on the right hand side also, and then multiply by e to the 2x. Okay, so we multiply the whole equation by this. And then the next step is that we are going to just look at this left hand side, and we are going to treat this left hand side as the derivative of mu of x times y. And then what happens is that we can also use the product rule to write out what this is equal to. And so if we do that, then we are going to, remember the product rule is that we are going to just differentiate the second function first, and then we do not touch the first function. Okay, so we are going to simply just write mu of x right here, and then we differentiate the y with respect to x. So we are going to get dy over dx. And then plus, okay, now the second term. This time we are going to differentiate the first function, but we do not touch the second one. So just copy, right? So we have mu, well, actually, instead of writing mu prime, I would simply just write d mu over dx. Okay, I think that's better. And then times y. And then, so now we have this expression. And we claim that they're both, this left-hand side of the equation and this expression that we are getting here are both equal to this derivative of the product of mu of x times y. Okay, so now what happened is that we can compare the two expressions and see what we are getting from here. So you can see that the first terms are exactly the same. We have mu of x and then times dy over dx. They're the same. Now, the second term, as you can see that they both have a y, so we only need to match the stuff that is attached to the y, right? So the original equation has this negative 3 mu of x, and then here we have d mu over dx. And so from here, by doing the matching, we simply will just get what? D mu over dx is equal to, okay, negative 3 mu of x. So we get negative 3 mu. Is that okay? And so now what we want to do is to figure out what mu is. And then you may say, what about the original equation? Let's forget about that for now. We will solve this equation. And how do we solve this equation? This is actually a separable equation, so we just need to separate the variables. And so we can treat the mu as the dependent variable, and then x as the independent variable. So move the mu to this side, and then move the dx to the side. And so we can continue to go from here. We are going to get 1 over mu, right? We divide mu from both sides, so we get d mu is equal to minus 3, and then we get the dx. And then what we can do is that we can integrate both sides. Okay, so now what? Next step is that we are going to just integrate each one separately. So we will simply just get ln of absolute value of the mu, and then equals, we get negative 3x, and then plus some constant. Let's call this constant k. Okay, so we have this. And if we want to find the mu, we need to exponentiate both sides. So we will just say e here and then e here. Okay, and then we are going to simply, we'll just get absolute value of the mu is equal to e to the minus 3x, and then plus the k. And then so what we can do is that we can remove the absolute value by writing plus or minus in the front of this expression here, and then we can also factor out e to the k here in the front. So we are going to get the expression to be mu equals plus or minus e to the k, then e to the minus 3x. And we can simply just turn this into, let's just call it C1, right? So we are going to get C1 times e to the negative 3x. And then when we say that we multiply an integrating factor for the whole equation, remember I said n, right? So we know that this is not unique. And then you may say, can we just choose any constant? Yes, the answer is yes, we can choose any non-zero constant that we have here. Actually, this is non-zero, so we cannot really choose 0 for the C1. And so you may say, why is that okay? The reason is that when we multiply the whole equation by mu of x, if we have whatever constant that we choose, you can actually cancel all those constants in this equation. So it doesn't really matter which one that you choose. The easiest one that we can choose, okay, is to choose C1 to be 1. So we should choose that mu, the integrating factor, to be e to the minus 3x. Okay, so now, once we figure out the integrating factor, we can go back to our equation. Okay, we can go back to this equation right here, but instead of using this expression, we are going to use the derivative of the product. And then the right-hand side of the equation will be this expression. Okay, so let's continue. We come back to the original equation. So write down this one. We have the derivative of mu of x times y is equal to, and then what do we have for the right-hand side of the equation? Mu of x e to the 2x. Okay, mu of x e to the 2x. So now we can replace the mu by e to the negative 3x here. So we are going to get the derivative of, we put that here, e to the negative 3x, and then y equals e to the negative 3x, and e to the 2x. Okay, as you can see that this can also be canceled. I mean, we can actually simplify, right? Not cancel. So we are actually going to write it as e to the, well, negative 3x and then positive 2x. We add them, we add the exponents together. We are going to get e to the negative x here. Okay, so now we can integrate both sides of this equation, because this is taking the derivative. So integrating it, we'll be getting just the stuff that's inside the brackets. Okay, so we integrate both sides, we get e to the negative 3x y is equal to the integral of e to the negative x dx. And then now all we need to do is to integrate this one and then isolate the y, and then we have finished solving the equation. So now integrating this one, that's easy. So we are going to get e to the negative 3x y is equal to negative e to the negative x, then plus some constant. Let's use c this time. Okay, and then okay, so now to isolate the y, we can multiply both sides of the equation by e to the positive 3x so that we can cancel this factor here. So let's do that. E to the positive 3x, and then the original expression, e to the negative 3x. No, actually, that's not correct. I should be just copying the stuff from the top, right? So it would be negative e to the negative x, and then plus e to the 3x, and then times c. And then as you can see here, we can cancel those two. So let's cancel them. And then we have the y isolated. So we get y is equal to, now this, there is a negative one here is the coefficient, and then e to the 3x times e to the negative x, we get negative e to the 2x plus c e to the 3x. And then we have the final answer. So that's the solution to this equation that we have here. Okay, and then that's our solution. Okay, so that's it for this problem. Thank you for watching. Please subscribe and share. I will see you next time.